Hey guys, today we're going to be talking about 12-1 and our learning targets today for flow chart proofs are to write a simple flow chart proof as a 2-column proof, and then we're going to write a flow chart proof all on our own. So here's an example given to us. So we have a regular 2-column proof that we've been working with so far this year. We have our given statement, we know where we're trying to prove, and we can see here that we're given a list of statements and reasons. Okay, well, when we're trying to go from a 2-column proof to a flowchart proof, notice that all of the statements are written in order in each one of these boxes. And all of the reasons, okay, are written below each box to the corresponding statement. For instance, our given is always what we're going to start with here on our left. Okay, our statement DB or ray DB bisects segment AC, that is going to go in the box, and the reason is given, that'll be written right below. Okay, and then notice that we have 3 statements written in one column, and they're all pointing arrows to our final statement, basically what we're trying to prove. Okay, so go ahead and flip the page. All right, so looking at number 1, why does it make sense that there are 3 arrows pointing to the box on the far right-hand side of the proof, the one we were just looking at? So maybe take a minute and discuss this in your groups and try to think, why would we have 3 arrows pointing to the box where we're trying to prove that the 2 triangles are congruent? Okay, guys, so I hope you all had good discussion. So why does that make sense? Okay, well, it takes 3 pieces of information to conclude that 2 triangles are congruent, right? We have side, 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 angle, side, angle, etc. Those are 3 different pieces of information telling us that our 2 triangles are in fact congruent. So it makes sense that then there are 3 arrows pointing to our final statement that the 2 triangles are congruent, because it takes 3 pieces of information to do that. All right, so now we're going to try going from the flowchart proof to writing our 2-column proof on our own. Okay, so when you're writing this flowchart proof, remember that your statements will be in your boxes. Okay, and so we want to start with our statements that were given to us. Okay, followed by 1, 2, 3 statements, and our final statement should be our conclusion that the 2 triangles are in fact congruent. Okay, and then all of our reasons on the right hand side of our 2-column proof should be the phrases right below our boxes. All right, so take a minute now to write your own 2-column proof from this flowchart proof. Okay guys, so now that you're finished with that, go ahead and check your answers with your group mates and your teacher. Make sure you were able to go from that flowchart proof to a 2-column proof. Okay. All right, so although we can use the flowchart format for any proof, flowchart proofs are usually most useful in longer proofs just because they show how steps are logically interconnected. So it makes reading a really long proof really nice because we can just follow the arrows and kind of see where we're going, starting and then where we're going. So the following sequence of steps will help you plan and write your flowchart proof. So I'm basically going to walk through numbers 2 through 12 with you in your book, and we're going to create our very own flowchart proof from this information right here, okay? And we're going to be looking back at this diagram while we're creating it. All right, so go ahead, flip the page over. Okay, so we already talked about how it's a logical sequence to organize our thoughts into a flowchart proof, or as I like to say, flow proof. So a significant difference between writing a paragraph of a proof and then a flowchart proof is justification. So when we're writing proofs and paragraphs, we don't necessarily have to make each justification super clear. A lot of times they're not written clearly. But with flowchart proofs, we have to have that reason below every single statement, right? Referring back to here, every single statement needs to have a reason written below it, okay? And so everything has to be justified. And we can only remember justify any statement, okay, using properties, definitions, the given that they told us, postulates, and theorems, okay? We can't just say, well, they look like they're congruent. No. We need something that's fact. Okay, so a flowchart proof, it can begin with statements based on given information or information that can be assumed. Okay, so that's always where you want to start in your flowchart proof, with the given or something that you know can be assumed from the given diagram. And then flowcharts will always end with the statement that you're trying to prove. Okay, so we want to always just figure out, hey, when we're starting this flowchart proof, where are we trying to go? Okay, so for number 3, okay, we want to fill in our very, very last statement. We want to know, where are we trying to go? All right, well, looking back, okay, where we started, so I told you guys that we were going to be, this is page 168, we were going to be starting with the given and ending with the proof. Well, this proof statement, that's where we're trying to go, okay? So segment AB is parallel to DC. So that's what we want to write in our very final statement, okay? We'll come back to the reasoning later. Okay, and then for where we're starting off, okay, these two statements we want to use as our given, okay? So we were given 2 statements, as you can see here. So we're gonna just go ahead and write those 2 givens in our starting statement boxes. All right, so in this first box, I'll put the first given statement. M is the midpoint of BD. And then right here we have M is the midpoint of AC. All right, so we have our first 2 boxes done. Well, now we need to give, now we have our statements, so now we need to give our reasons for that. And the reasons is, well, we were given these 2 statements. Okay, so now we're going to come to boxes 3 and 4, and it makes the most logical sense to come to these next boxes because these are the boxes being followed by these arrows, right, from our given statements. So whatever statement we write in each of these boxes, it should directly follow from our statement before, okay, since our arrow is pointing and following through to these boxes here. Okay, so what makes the most sense, what statement makes the most sense to write in box 3 if we know it's coming from the statement that M is the midpoint of BD? Okay, well, if you don't remember midpoint, maybe get out that little flip book of yours, go back, look at the definition. Well, we know that if M is the midpoint of this line segment, then it should split this line segment into exactly 2 smaller segments of the same size. So number 1, it tells us that BM should be congruent or equal in distance to DM. Okay, so let's go ahead and write that down. So BM is congruent to segment DM. Okay, and I'm just gonna mark our figure as we go, which you should always do so that you can kind of know which parts are congruent to each other. Okay, so number 4, same thing, okay? If M is the midpoint of our segment AC, then I know that AM is congruent to CM. So go ahead and write that. So segment AM is congruent to segment CM. Okay, now number 5. Oh, let me write that. Draw that on your figure, okay? Number 5, we see that there's no arrow pointing to it, right? It didn't directly follow from any other given statement, okay? So number 5 is going to be a piece of information that we know to be true by just looking at our graph, okay? It's not going to directly follow from anything else. So why don't you go ahead, take a minute, discuss in your groups, what other pieces of information do you know about your figure just by looking at it? And remember, don't ever assume anything is true. We need to know it. Our reasoning needs to be justified using factual evidence. So properties, theorems, postulates, etc. All right, so take a minute and discuss in your groups what you think number 5 should be. Okay, guys, so you were just discussing if there could be more information assumed from the diagram. Well, hopefully you guys were able to see that we have 2 pairs of vertical angles. Okay, we have AMB and CMD are going to be congruent angles because they are vertical angles. We also know that these 2 angles on the other sides are congruent. But since we're specifically looking at these 2 triangles, I'm going to just go ahead and write down the fact that AMB is congruent to angle CMD. Okay, and I marked my 2 congruent angles there in our picture. Okay, so the reasoning for that, well, vertical angles are congruent. We know that for a fact. So that is a good justification to put here. Good reason. Okay, so now what I want you guys to do is discuss in your groups what you think could follow from parts 3, 4, and 5. So notice this is the part of our flow chart where we have 3 arrows all pointing to one box. So whatever statement is going to be written in box number 6, it needs to directly follow from all 3 pieces of information. Okay, so what can we include given the statements written in 3, 4, and 5? Okay, so take a minute in your groups right now to discuss, and then we will come back. Okay, guys, so I hope you guys had good discussion. Well, we know that these 2 segments, BM and DM, are congruent. We know segment AM and CM are congruent, and we know that we have these 2 congruent angles. Well, I hope that when you were looking at your diagram, you saw that we have a side, angle, side, and side, angle, side on 2 triangles. Okay, so if we have side, angle, side, well, that's one of the congruence postulates that we have learned. Okay, and that tells us then that triangle AMB, sorry guys, that was a terrible triangle, looks more like TP. Okay, triangle AMBB is congruent to triangle CMD. Okay, and we knew that these 2 triangles were in fact congruent by side, angle, side. We were able to follow along the sides of our triangle, and we got a congruent side, congruent angle, and another congruent side. All right, so for number 7, okay, it's following from the fact that these two triangles are congruent. And then we know where it's going is that we can conclude AB is parallel to DC. Okay, this line AB and DC are parallel. So what pieces of information that follow from number 6, what pieces of information could help us determine that these two segments are in fact parallel? Okay, maybe think back to some of those converse statements or to some of those converse statements that we learned not too long ago, maybe just a couple weeks ago now, when we're talking about parallel lines and angle relationships in a diagram. Okay, so take a few seconds to talk about this in your groups. Okay, guys. So for part 7, there were a few things that we could have concluded following number 6. We have several congruent segments like AM and CM. We have a segment AB is congruent to segment CD and so on. We also know certain angles are congruent. Angle A is congruent to angle C, angle M is congruent to angle M, of course, and B is congruent to angle D. Well, so which pairs or which parts of those information are going to help us conclude that AB is in fact parallel to DC? Well, thinking back to some converse statements that we wrote when we were talking about angle relationships and parallel lines when they're cut by a transversal, well, we see that AB and DC, it looks like they are cut by a transversal. Okay, and we know that we do have certain segments are congruent, but knowing those segments are congruent isn't really going to help us say that these two lines are parallel. What will help us though is knowing that we have a pair of alternate interior angles that are congruent. Okay, so if we're looking at angle MBA and MDC, okay, so let me just mark that by 2 lines. Okay, these two angles are alternate, right? They're on other sides of this transversal line. Okay, we know they're congruent, right? Based on our congruent triangles, right? We have corresponding parts of congruent triangles that tell us B and D are congruent. So since these angles are in fact congruent and they're on alternate sides of this transversal, okay, then we can conclude that angle MBA is congruent to angle MDC. We know that by corresponding parts of congruent triangles, they are congruent. And we also have another pair of angles that would help us prove number 8. If we look at angle MAB, so MAB, I'll mark this with 3. Okay, so angle MAB is congruent to angle MCD. Sorry guys, let me get that a little cleaned up right there. It's a little messy. Okay, that's fine. Okay, here, 3. All right, so A and C are congruent. We know because of corresponding parts of congruent triangles. So let's go ahead and write that. Angle MAB is congruent to angle MCD. Okay, by corresponding parts of congruent triangles, we know they are congruent. Well, this helps us because since these angles are in fact congruent and they're on alternate sides of our transversal and they're on the interior, that tells us that since they're congruent angles, that AB must be in fact parallel to DC. Okay, so for part 8, our reasoning for that, well, if two lines are cut by a transversal, and alternate interior angles are congruent, I'm just gonna put my little symbol for congruent for short, are congruent, then the lines are parallel. So that was a converse statement we learned a couple weeks ago when we were talking about relationships between angles. Well, there you go. All right, so we have just now walked through steps or numbers 2 through 12 in our books. Okay, and we just completed our very own first flowchart proof. Awesome job, you guys. Okay, so now go to page 13, or number 13, sorry, not page 13. Go to page 173 and look at number 13. Okay, so now with the flowchart proof that we just created, okay, this one on page 171, use this flowchart proof to now convert it into a 2-column proof. Okay, so remember all of those statements, those are the ones in the boxes. And so you'll start with your givens and you'll follow it with your 3 boxes in the middle. Okay, and then make sure that your arrows flow to each statement that comes after it. And then your reasonings are all of those reasonings right below. Oh, and I realized, guys, I'm sorry, when we were doing our flowchart proof, we never wrote our reasonings in below 3 and 4. And the reasonings for those two, well, we knew that BM was congruent to DM because M was the midpoint. So our reasoning for knowing they're congruent is the definition of midpoint. All right, and it's the same thing for 4. We found it the same way, definition of midpoint. Okay, my bad, you guys. All right, so now that you have all your statements, all your reasons, convert that into a 2-column proof. Check with your groups, check with your teacher, make sure that you did it right. And that's gonna be all for today, you guys. All right, well, you guys have a good rest of your day. And that is flowchart proofs. Let's just really quickly go back to our learning targets. So let's see, were we able to write a simple flowchart proof as a 2-column proof? Well, we sure were. We were given the flowchart and we put it into a 2-column proof. And then that's what y'all are about to do again right now in your groups. And then second one was write your very own flowchart proof, which we just did together. All right, so great job, you guys. That's the end of 12-1.